write as a F is equal to BIL in vector form. So in vector form we can write F is equal to BIL. So that is the formula we have derived in the last class. Today also we think about the straight conductor. Right? So first we go through our previous class. Once we see the derivation of force exist in a conductor, then what is the field strength of a straight conductor in a magnetic field. So those things also we want to see. Then after we go for the concept of when two parallel conductors is placed. So also here we discuss only about a single conductor. Whenever we are placing a two conductors, what is the force existing on one conductor and another conductor. So those things we want to study today class. So last class we discussed about the force acting on a straight conductor. So we are taking a conductor, it is having a cross length as a dl. We are assuming the current I will be flowing through that conductor and a point P. So this is we are assuming as a magnetic field. So it is we are assuming as a magnetic field. In between the magnetic field we are placing a conductor. So just we are assuming a point P and it is having a pole strength. Pole strength it is donated by means of small m according to the Coulomb's law. So for the force is directly proportional to the product of the pole strength and inversely proportional to the distance between that. So d square. So 4 pi d square, finally we are deriving the equation. So those things will be we discussed in the last. So just we are assuming the point will be placed at P. At point P that is a unit north pole. Unit north pole is placed at point P and it is having the magnetic field strength as a small m. So already we derived in the previous class about the what is the magnetic field strength. Strength is donated by means of capital H. We are assuming the distance between those two is the R. R is the radius between point P to the center of the conducting material. So whatever we are selecting there. So that thing will be, we are assuming at the same time the angle made between those, it is we are assuming as a theta. So from this data, so already we derived the equation, the field strength. So it's nothing but H is equal to I into dl sin theta by 4 pi r square. 4 pi r square. So this is the field strength at location. So whatever we are assuming around that state, so it is having the magnetic field strength, that is the H. So already in the previous classes we discussed about the relationship between field strength and density and as well as the permeability. So we have the relation that is the B is equal to mu into H. So we are substituting the H value in this equation. So means mu into H is nothing but instead of H we can write as a I dl sin theta by 4 pi r square.
नमाज काफी हो गई
4 pi r square.
यहाँ तो
So this is a density we can obtain here. But the total strength, this is only for the a small portion whatever we have selected. But if you want to find out a location P, it is also having a field strength that is a small m. So means we are assuming this entire portion is we are assuming as a m2. So just where it is assuming as a m1. Means so the force can be directly proportional to the product of their pole strength. What we are assuming, whatever we are finding the pole strength, so that is we are assuming as a pole strength at entire field, that is B, and we have the another pole strength, it is at location P, we are assuming as a M1. Actually this is a M2 and this is we are assuming as a M1. So we are find out for the conductor only, but actually what is the position? At position of P, what is the magnetic field strength? That is the M1. But instead of M1 and M2, just we are assuming this is the M and this is we are assuming as a M2. So from that we can simplify and write down an equivalent equation. So that is the force. The force exists between the two poles. Df is equal to the product of two pole strength M1 and M2. So he can write as a M into mu into I dl sin theta by 4 pi r square. These are all the constants. 4 pi is a constant, radius is constant, m value is constant, mu is constant. But what are the variables is there? The current is variable and the angle between the conductor and as well as the pole can be changed. So we are separating the constant and variable. So m mu by 4 pi r square. Remaining I into dl sin theta. dl sin theta.